Hi, my name is Danny Finn, and I'm a member of the Wolfram Tech Consulting team. And today I'm presenting on Quezzio, instructional precision driven by computation. So some of you might have already seen the abstract. There's two main components to this presentation today. The first one is what is Quezzio? So I'll explain what that is. And then secondly, how can we use LLMs to speed up the process of authoring our own questions inside of Quezzio? So diving straight in, what is Quezzio? So Quezzio is our learning and assessment platform built by us in the Wolfram Tech Consulting team. The website for it is available here, so quezzio.com. And if you were at last year's conference or the year before that, you might have already seen this as Wolfram EdTech Learning Environment, or WEAL. So Quezzio appears inside of the Wolfram products page. And this is an application that was originally developed for colleges and universities, but also enhances K-12 learning in exactly the same way. Quezzio allows you to do three things. So firstly, and these are author, answer, and assess. So firstly, it allows all instructors to create their own questions, to create structured templates, to generate questions, answers, and solution steps to go with them as well. Answer. So Quezzio allows students to fill in answers through our web interface in a way that performs automatic typesetting of mathematical answers. So we have templates inside of here for fractions, powers, square roots, and so on to make it really easy to enter mathematical answers, as well as united quantities and so on. Assess. So Quezzio automatically grades students' answers using an understanding of the different acceptable equivalent forms that the answers may come in. So ultimately, this is using the Wolfram assessment capabilities, which Bob was talking about in the presentation just before this, if you were at it. So basically, this is making use of the Wolfram language's understanding of mathematical equivalence and different notions of mathematical equivalence, as well as applicable or applying similar notions from kind of quantities, chemistry, physics, and so on, in order to assess whether the student's answer should be deemed correct or not. It also provides feedback to the student on how they did, as well as providing step-by-step solutions to the student to help with learning. And in today's presentation, I'm going to mostly focus on the part of authoring questions and how we can use LLMs to speed that process up. At the core of Quezzio are question generators. So what is a question generator? So what do I mean by that? So what I mean by a question generator is essentially a function that can generate multiple solvable versions of a question. So in its simplest form, if we have a numeric question, each version of that question might have different numeric values inserted into it. So say, for example, if it's really simple, it's an addition question of two numbers, the numbers in each version of that question will be different. And as a result, the answer will be different too. So we then extend this, though, to much more complex scenarios. So it could be kind of multiple numeric values all combined together. It could be choices from a selection of strings or locations, or pulling in from entities, generating graphics, generating intermediate steps along the way. So a question generator does quite a lot. And why would you want a question generator? So if you are an instructor and you have an assignment and you want to generate an assignment where each student sees a different version of the question, this is a way to do that. Say, for example, if you want to encourage or if you want to discourage cheating, because students can't copy answers from one another if every one of them has a different answer, and encourage collaboration by sharing of understanding, this is a good way of doing it. If you're a student who's just completed an assignment and feels that some additional practice could help to get this to sink into your brain or just improve your understanding, question generators are a really good way of doing that. Question generators allow you to generate PDF problem worksheets, and they're a good, reliable way of providing reliable questions to AIs. The solutions and answers in these are generated computationally for each question. So what we mean by that is that there is code that is run each time we generate a question. And this is deterministic. So computational generation removes the possibility of mathematical errors which may occur when questions are generated by LLMs. So we all know that LLMs make mistakes sometimes, and they might do a really good job of generating questions most of the time, but if we are putting questions before students, we need them to be reliable. We need the questions, the answers, and the solutions all to be reliable and to conform to the way that we want them to be presented. So how can we access these Quezzio questions? So the simplest form is that we have a PDF worksheet. So this is an example of that. So here we have a basic integration question. We have 6 different versions of it. They, as you can see, have different wording and different numbering. And we have them all in one single worksheet. We also have the Quezzio web interface. So we do have a web interface for Quezzio. Students can go in here and browse through the different assignments that are available to them, as well as providing answers to questions, seeing their grades, and then also seeing solution steps. Quezzio can integrate into pre-existing LMSs. So if you are already using, for example, Canvas, Blackboard, Moodle, your students will be able to sign into that platform and access Quezzio directly from inside of there using what's called the Learning Tools Interoperability Standard. So essentially, they sign in the normal way. They don't need an additional login for Quezzio. They sign in through their pre-existing LMS, and it feeds them directly into Quezzio. We can also access this through web APIs. So essentially here it's we have certain APIs for pulling in questions. We have APIs for grading students' answers, and these are mostly applicable for edtech companies who might want to make use of aspects of Quezzio to plug them into a pre-existing system that they have created. So this is just showing a curl command that's returning a list of questions. Okay, so if we want to create good, high-quality assignments for students, we need to have good, high-quality questions. And there's 4 ways that we can assemble questions. These are to author your own questions, author your questions with assistance from AI, deploy pre-made question banks that we have made in Wolfram, or let us in the consulting team help out. So in terms of authoring your own questions, this is something I'm going to, well, essentially this is something that was a core component of Quezzio right from the very start. So we have always had it as a key component of Quezzio that instructors would be able to create their own questions from scratch. And then now we've added in tools to speed that up by allowing LLMs to help with certain components of that. In terms of the pre-made question banks that we have, I'm going to go into that in a little moment. And then in terms of kind of like letting us in the consulting team help out, we've kind of built up experience through creating these question banks, as well as created tools for ingestion of kind of a mass ingestion of pre-existing questions to speed up this process. Okay, so the simplest starting point in terms of assembling a set of questions is to make use of our pre-made questions. So we have 2 question banks which are available inside of Quezzio. One is our US Common Core State Standards for Mathematics set. So this is a set of largely worded and visual problems, which also contain typeset math and generated graphics. And these were specifically written to align with grades 4 through 12 of the US Common Core State Standards for Mathematics. Inside of this, there are, I guess for each standard in the US Common Core standards, we have 10 different question generators spread across 5 difficulty levels, totaling up to 4,000 algorithmic question generators. Each of those generators can generate multiple instances. So like kind of if you want to have like 100 versions of one of these questions, you just tell it that you want 100 versions and it'll generate them. They'll have different visualizations, different numbers, and so on. So inside of here as well, and this is something to go through in your own time, we just have a breakdown of what these different US Common Core domains are. So what are the topics that are covered inside of this, and the number of question generators that we have inside of each of those. So you can go through that after this. Second question bank that we have available is that we have the ability to pull in questions directly from the pre-existing Wolfram problem generator. So Wolfram problem generator is something you might already be familiar with. This has been around for a while and has been made available through Wolfram Alpha. But with Quezzio, we have the ability to pull those questions in. This covers 6 topics. So arithmetic, number theory, algebra, calculus, linear algebra, and statistics. And these questions are largely pure math problems with typeset formatting of mathematical components inside of them. So in total, there's roughly 360 algorithmic question generators, and these are split into 3 difficulty levels of beginner, intermediate, advanced. For each of these, there's solution steps generated by Wolfram Alpha. And again, we have a full topic list here listed so that after the presentation, you can go in there and have a look through in your own time. So, authoring your own questions. In order to do this, we have a Mathematica notebook, which we call our question template notebook, which we use to write our own question generators. This has a couple of components to it, starting with the question cell. So this is where we define the question. And this is a standard Wolfram notebook cell. And as a result of it being a standard Wolfram notebook cell, we can enter text, we can enter typeset math, we can enter quantities with units, graphics, images, whatever we want in there that you would normally be able to enter into a standard cell. And as well as this, we have 2 template slots that are used inside of these 2. So we have evaluating and non-evaluating template slots. So the evaluating one is if you want to insert values and then perform a computation, for example, generating graphics or generating a grid. And non-evaluating is essentially evaluating content in held form. So you can inject values in, but then have it sit or have it display directly as you insert it rather than evaluating something as well. The solution steps are defined in the same way as the question, just we have multiple of them. So we just define step 1, step 2, step 3, insert the values, perform computations. Random variables allow us to generate varied instances, and this defines the ranges through which these values should go. So when we're generating questions, we kind of want them to be consistent in terms of difficulty. So we want to choose ranges that support that. These random variables can be, for example, random integers, random strings, random choices, random entities. So there's quite a lot of scope in how you define your initialization of the problems that we generate. And then from that, we generate computed variables. So these are intermediate values or intermediate results that take us from those random variables as initialization conditions to our answers and any additional values that we need to compute in order to fill in our solution steps. When we're defining our answers, we define the correct answer definition, as well as filling in, like, does it need a tolerance? What notions of mathematical equivalence do we want to allow? Do we want to have an interpreter? For example, if it's a quantity or if it's a certain entity type. And these can be either free response answers or they can be multiple choice as well. Also inside of the template notebook, we have the ability to generate preview instances, as well as testing the grading directly inside of this notebook, and also previewing what an instance of the question would look like in a web interface as well. But this seems like quite a lot of fields to fill in, so this could be quite a bit of work. So the question here is, can we use AI to speed this up while still retaining full control? And in doing so, can we simplify this for anyone who's new to the Wolfram language? So these computed variables and so on are defined as the Wolfram language. So can we make this more accessible to people who might not be quite familiar with it? And the answer is yes. So this is basically we created a small interface where the author can provide a question in the form of text or an image of their question. So here's an example: compute the tangent to the polynomial 3x squared plus 9x minus 2. And then you click generate. We have an LLM there that's familiar with the structure of the template, how each of the parts interconnect, how it should generate ranges and so on, which creates an initial version of the template for us. So this really speeds things up. But again, this is being generated by an LLM. And LLMs are not always completely reliable. So we need to make sure then that we have a human in the loop step, that after the LLM generates an initial version of this template, that we can go in and edit that, get it into just the form we want, make sure everything's correct. And then once we've finished our human in the loop refinement, then we have a question that we're ready to feed into our Quezzio web interface and make available to students. But again, it's really, really important that we don't just allow the LLM to kind of try to do this completely by itself, that we do also have a human there making sure that they do everything in the way that we need. So here's a few examples, just kind of, I feel this helps a lot in understanding what these templates actually do. These examples are taken from the OpenStax book, Elementary Algebra, 2nd edition. This book is under Creative Commons licensing, and if you click on this here, you'll be able to see what the terms of that are. But so here we have an example. We have find the equation of a line with the given slope and y-intercept, and we're taking these 4 versions of this question, and we're trying to generate one template to cover all of those. We can see that the slopes change, we can see that the y-intercepts change. So here we're going to define the slope as m and the y-intercept as b, and we're going to define ranges of those that get inserted into our question template up above. We can do the exact same thing for solution steps. And not only that, we can kind of get typesetting and so on to go into this as well. So like we can see here, M1 and M2 are the slopes of 2 parallel lines. And our numeric values get inserted in too. Equally, we can generate graphics. Again, we have the Wolfram language at our disposal here. So everything that we're defining inside of here is defined using the Wolfram language. So if we want to define plots to insert here, or if we want to define tables or graphs, we can insert them in the same way as we would anything else in the Wolfram language. And also, because we're working with Wolfram cells in this way, it's actually quite easy to generate worded questions. So here we're kind of filling in certain bits are just text, and we're inserting values into that to generate different versions of the question with generated graphics inside of it as well, generated answers and so on. So earlier on, I mentioned the human in the loop stage. And I think one thing that's really important to note on this is that if you were to just generate questions with an LLM and you didn't have the ability to refine them afterwards, it gets really, really frustrating. So recently, me and some friends entered into a triathlon as a relay team. We were making t-shirts, and we are not very good at designing images or anything like that, but we wanted to put something on our on our t-shirts. So we asked an LLM to generate a logo for us, and we didn't have any way to modify it afterwards. It kept doing something that was like 80% right, but not quite right. It didn't always, like it really didn't look just the way we wanted it. And it was like, you try it again. It's really, really frustrating. Having a system like this template notebook that we have, which was designed to allow authors to write their questions from scratch, means that whatever change you want to make to that initial version that the LLM created, you can. And that's really, really important when you need something that is robust and is ready to be put before students. If you're creating questions, or say, for example, if you're creating a textbook, you can't have questions in that textbook that are wrong. Like, that's not acceptable. So we need to have that tool, which the Quezzio template notebook gives us to get it across the line, to review, refine, and test anything that we are generating. And like, so this is just like what are the things that we're looking out for? So we're making sure that the numeric ranges that are used are consistent, that the grading rules that are being applied are in line with what we're trying to teach the student, that the learning objectives are met, and the generated graphics are correctly labeled and represented. And then once we've got an initial version of the question, one thing that feeds really well into this is actually the Wolfram Notebook Assistant. So given that we are defining our questions inside of a notebook, the Notebook Assistant just works. Like, so if we're new to the Wolfram language and we want it to explain Wolfram functions, we can just say, what's the function to differentiate a polynomial? It tells us, we copy it straight in, and we move on. If we want to say we have a problem here that, so here we have a tangent to a polynomial problem, and I keep using this example because it's a nice one. And we say, now that we have the equation of the polynomial and the tangent, how do I use Wolfram to plot them? And here it's actually taking our computed variables from inside of this, and it's taking these values from inside of here as an example. So it says, here's the code that you need to use that, and here's an example if you want to see what it looks like and run it straight here. Because the Wolfram Notebook Assistant is able to pull in context from the notebook directly and make use of that. So it kind of integrates really, really smoothly. This one, I think, is the one that I like the most, getting it to suggest improvements. So we've generated a problem, and we've kind of generated solution steps as well. And we say, please verify that the selected question and answer are correct, and identify any grammatical, mathematical, or styling corrections that could be made to improve the student understanding. And straight away it says, here's things you've done well, here's things that can be improved upon. So it's kind of like, maybe there might be some inconsistency in your naming conventions that are used, and it's going to tell you, hey, this could make things a little bit clearer if you explain it this way. So really, really nice tool. Okay, so just some conclusions. So Quezzio does three main things: author, answer, and assess. It's useful for instruction in K through 12 and higher ed learning. So in terms of like who we're looking for as customers for Quezzio, this would be like university professors who have a class, or university departments who have a bunch of classes where there's assessment that needs to be performed, where it would really, really benefit from automatic grading that has a strong understanding of different notions of equivalence that might be applied in different scenarios. Similarly, in K through 12 education, if we have like certain schools that have students that they want to assign homeworks to, then this is a really good platform for that. EdTech companies as well, who also want to create applications to be used by students to help with learning, that want to be able to generate questions and perform grading inside of that in a reliable way. That's exactly who Quezzio is for. Right now we have 2 Wolfram-made question sets. We are working on more as well. And also, well, I guess kind of like one thing that I showed in this is ways that when we are writing our own questions, ways that we can use LLMs to assist in this, and then just kind of emphasizing that having like basically the interface that we have, our template notebook interface in Quezzio, gives us a really nice environment for refining these LLM initiated templates. And then just finally, we in the Wolfram consulting team have been putting together programmatic workflows for ingestion into Quezzio. So for example, if there is kind of like a textbook in a computational format that you want to ingest the exercises from in a certain way, say for example, if you're a publisher and you want to make these questions available in that kind of a way, then this is something that we can help with as well. Just some useful links. So this is the Quezzio website, also wolframconsulting.com. The Quezzio website actually got updated very recently to include a whole load of extra useful information to do with Quezzio. And you can get in touch with us through either of these. Both of them will link you into us. Just some related presentations. So the presentation before this This was actually also Bob S. Sandheinrich as well was also presenting this one on the question framework and applications for computer-based math. The presentation just after this as well by Theo Gray and Bob Sandheinrich on the Wolfram Tutor is also very closely related to this. Jason Sonnenberg will be giving a presentation on chemical education tomorrow, and inside of Quezzio we are creating more and more chemistry examples inside of Quezzio, and then John McNally will be giving a presentation on Friday as well on essentially use of AI in improving assessment in I think higher ed scenarios. All right, so I think what I'll do is I'll just check what questions they are. So there's a question here. So how compatible is it with STEM courses like chemistry and biology? So yeah, really good question. So Quezzio, as I was saying, makes use of all of the capabilities of the Wolfram language. So if you want to generate questions from chemistry, for example, and you want to make use of chemical data, or you want to make use of the molecule plot and so on in creating interesting and visually pleasing questions, Quezzio is really good for that. For biology as well, we have inside of the Wolfram knowledge base, we have a whole lot of information to do with anatomy as well as kind of taxonomy and different cell structures. And again, we have access to all of that because we're building this based on the Wolfram language. Okay, and then there's just a comment as well that human in the loop is a really nice step. I think that's all the questions. I do have kind of a little bonus bit here that I might just show as well. So as part of creating Quezzio, we were making heavy use of comparison methods inside of assessment function. And for anyone who's kind of not familiar with these, essentially this is different notions of mathematical equivalence to apply in different scenarios. So say, for example, if the answer is x minus 1, x plus 1, depending on what comparison method we use, this might be like these different answers might be marked correct or incorrect. If we have a question, for example, if it's factorize the polynomial, we don't want students entering the question as the answer. If we have a question where it's differentiate this expression, we don't want people entering the question as the answer, but we don't mind if they have factorized it or not. So one thing that in Quezzio is quite important as well is like, what if we want to thread multiple of these together? What if we want to, in a way of kind of like scoring answers as well as providing explanations. So say, for example, we have a question, a student is asked to factorize this polynomial. And say they provide the correct answer, but in the wrong form, or something that's mathematically equivalent to the correct answer, but is not in the form that we expect, then in that case, we want to have a way to handle that. And we want to provide potentially partial scoring, or we might want to provide just an informative explanation to tell them that they've kind of got it partially correct. And so we created this resource function called assessment tree specifically for that. So this allows you to thread a series of assessment functions one after the other. And so this is something, it's in the resource function repository. You can go in there, check it out. It's something that we built because this was a useful thing to have in Quezzio, and it was also a really nice thing to make available in general as well. So essentially this is a generalization to assessment function that just makes it a little bit more flexible to thread things together to get more complex scoring and explanation scenarios covered. Okay, cool. Nice. All right. I think that's it. Thanks very much for attending. Bye.